Okay, so here we've been presented with an equation. So nitric acid reacts with beryllium hydroxide to produce beryllium nitrate and H2O. We've been asked to work out the mass of beryllium nitrate produced from the reaction. But how do we do that? Well, we know that the mass is equal to the number of moles N multiplied by the molar mass, right? And we can work out the molar mass of beryllium nitrate from the periodic table, but we cannot, at least not directly, we cannot work out the number of moles of beryllium nitrate from the periodic table for this specific question. But what we can do is we've been told that the mass of beryllium hydroxide is 21.35, and we've been told that it's the we've been told that the other reactant, the HNO₃ is in excess. So we know that the beryllium hydroxide is actually the limiting reagent in the reaction. We know based on that actually the beryllium nitrate that's going to be produced is going to be contingent on the mass of beryllium hydroxide that was reacting. So so let's go from there. So we need to work out from that. If we work out the amount of substance for beryllium hydroxide, we can use that to work out the mass of the beryllium nitrate using the ratios in the equation. So to work out the moles of beryllium nitrate, that's going to effectively be the mass divided by the molar mass, right? So we don't have the molar mass of the beryllium nitrate. Beryllium hydroxide, right? We don't have the mass. We have the molar mass of it. We're gonna work it out from the periodic table, right? So, so beryllium hydroxide. So as you can see, the beryllium, you've got a molar mass of, well, relative atomic mass of 9, which will lead us to what? Our molar mass. So Be, and then we've got hydrogen here and oxygen here, right? So we're looking at BeOH2, right? So effectively that's going to be 9 as related to the beryllium plus 2 times 16 plus 1, right? So that's relating to the OH, so 9 to 16, and that's going to give us the MR. So for BeOH2, the MR is equal to effectively this. So if you have a go and work that out, what you should find that you get is 43. So, and that's going to be in grams per mole. All right. Now with that value, what we can do is we can use that to work out the number of moles, right? So number of moles is equal to that. And for this question, that would be 21.35, right? So that's the mass of the beryllium, and divide that by 43.0, right? And so what does that give us? So if you do that calculation, what you should find is you get 0.4965116, right? And if we look at this and relate it back to the actual equation, what you find is actually when we compare the moles of BeOH2 with the moles of beryllium nitrate BeNO3, you can see that in both cases the coefficient, even though there's not a coefficient literally written there, the coefficient is more or less is 1, right, for both of them, and therefore you can say that the moles of BeOH2 is effectively, when we look at the ratio compared to the moles of BeNO3, that is effectively going to give a 1-to-1 ratio. All right. Now, because it gives a 1-to-1 ratio, what we can do from that point is to say that, well, therefore, the moles of BeOH (2) is equal to the moles of BeNO3 (2). Okay, and because of that, we can say that therefore the moles of BeNO3 (2) is equal to the moles that we just calculated, right? So it's going to be equal to 0.4965116 moles. All right. But we've been asked in the question to work out the mass, right? So we still have some steps to do yet. We need to get the molar mass, right? In order to actually work out the mass, because we know that the mass is equal to the moles multiplied by the molar mass, right? So in this case, therefore, well, let's work out the molar mass first, right? So before we go into all of this, so the molar mass of and I think I forgot to put some brackets, so let me just put one additional bracket here, right? So yeah, it looks better. BeNO3. So now we're looking at the MR of the BeNO3 (2), and that's going to be equal to what? So we know from beryllium the relative atomic mass is 9 plus, and then that's going to be, so for NO3, I'm going to put a 2 here, open the brackets, and so for nitrogen we've got 14, right? 14 plus. For the oxygen it's O3, right? So you actually have to do 16 times 3. 16 times 3. And yeah, so that's going to be, because we've already got the 2 on the outside anyway, so that's fine. So if you work that out, you're going to get the molar mass of the beryllium nitrate. Okay, so if you had to go figuring out what that would be, you would have found that you got 133.0, right? And that's going to be, so it's a molar mass, so it's going to be in grams per mole. Okay, so as we remember, the mass is the mass is the number of moles multiplied by the molar mass. So we've got that the molar mass is 133. So what we can write at this stage is, therefore the mass of BeNO3 (2) is equal to the molar mass multiplied by the mole. So that's going to be 133, which we just worked out, right? 133 multiplied by 0.4965116. Okay, and that's going to be 66.0360465 grams, right? And the question specifies, please give your answer to a maximum of 2 decimal places. So let's make sure we also adhere to that. So Therefore, that is equal to 66.04, right, to 2 decimal places. Okay.